Alright guys, and we are back over here. So today we are going to go over nutrient cycling. So we're going to look at the carbon cycle, the water cycle, the phosphorus cycle, all in one video. So 1.4, 1.5, and 1.6. So let's start off with the water cycle. You guys know it. This is my beautiful little design. So we're gonna start off on page 70. Most of this stuff is already explaining where everything's at, so you guys should know what nutrients are. They're basically the elements that help us live our daily lives. So we call the cycles biogeochemical cycles or nutrient cycles, basically because without them we wouldn't really be able to live life on this planet. So we'll start off with the water cycle. So on page 70, they'll give a bit of an overview of what it is, the importance of the water cycle, and how basically we've created effects due to that. I do want you to look at basically what happened in Flint. So why is water important? That's the essential question that you're gonna answer when we get back to class. Think about Flint, what happened in Flint, why was their water so polluted, what led to that, and why haven't we done anything about it? There has been some change there, but it has not been due to government. So I want you to look at that too. Alright, so let's go over simple water cycle. Okay, so page 71, I just want you to look at the figure. You guys should know it by now. Okay, so simple water cycle. Let's start with our surface runoff. So basically we'll get water coming into whatever ocean storage it is. So it can be the ocean, it can be a lake or whatever. That will evaporate. So we get evaporation from land, evaporation from the ocean, evaporation even from lakes and rivers. Also, groundwater also moves throughout the bottom of our earth and into these different ocean storages. Okay. Once it evaporates, and then we got transpiration from plants. So this is actually from the ground, from plants. We'll get condensation, creates the clouds. These rain clouds then create rain. In other words, rain is precipitation. Alright, you guys should know this from grade school. So water cycle has not changed since then. Okay, next one is gonna be my favorite, the carbon cycle. So basically this is just different types of CO2 that has gone through different forms throughout the land and converted and helped other life processes. Okay, so here you're gonna use this giant chart over here, so we can start with let's start with the air. So the air actually is about 0.038% CO2. It's probably higher now. So if it makes it any easier, we know that CO2 is used for different processes, including one of our favorites, photosynthesis. Okay, so photosynthesis basically converts CO2 into sugars and oxygen to breathe. That same oxygen is then diffused in animals and other organisms, and CO2 is sent back into the atmosphere in different ways. CO2 is also created from death due to fossil fuels, and combustion. Okay, so combustion is the end products of combustion are CO2 and water. So we get a lot of CO2 in the atmosphere due to combustion, and we get that either from fires or from burning fossil fuels, which most of you know is basically what we use for gas. Okay, same thing in the oceans. CO2 is actually converted into photosynthesis due to the producers in there. So the algae, the seaweed, etc. that's consumed by plants and other mammals that are also in the ocean. They breathe out the CO2, creating that cycle all over again. The sediment, still the same thing. So when animals die, they go into the sediment. They create fossil fuels that creates the gas and petroleum that we need for combustion, and the cycle runs all over and over again. Okay, so I want you guys to focus on this essential question. So, what do carbon emissions affect? How do carbon emissions affect the CO2 cycle? So, I want you to look up the PCFs. So, phosphocarbofluorides. And this scientist, his name is Mario Molina. So, PCF, and look up Mario Molina. Okay, huge Latino in the science community, and has turned heads due to his findings. All right. Ooh. Now, the fun one, nitrogen cycle. Okay. So we will start again in the atmosphere. So nitrogen cycle actually includes one more organism that is very essential to our living, especially now. So nitrogen cycle mostly. So we have N2 in the atmosphere. Okay, regular nitrogen gas in the atmosphere. Nitrogen gas is fixated actually in the soil and by plants, and creates ammonia. So some of the ammonia is lost by leaching, other ammonia is used for nitrification. So this ammonia actually goes into the roots of the plants, creating very rich soils, and can eventually lead to huge crop yields. So with a good amount of ammonia and nitrite in the soil, you can create a larger yield. So one of the things that actually creates this nitrite is the mycorrhizoids. So mycorrhizoids are actually a nitrite fixating bacteria that live on the roots of some plants. So you can actually get a lot of nitrate from different parts, but it's that bacteria that actually helps in the yielding of many of these plants. So again, nitrite turns into nitrate, and then it's uptaken again, same thing. If it's from plants, then the animals then eat the plants, and through their excretions or their death, create nitrogen-rich waste. Again, ammonification, so it becomes ammonia. That ammonia will eventually be turned into nitrite again, and so the cycle continues. Okay, so again, there is leaching, and this cycle is not perfect. Okay, cycle is not perfect, but it'll always come back to becoming something positive for specific plants and animals and even us. So if the ammonia is taken up by autotrophs, so plants, again, it'll just be excreted down, nitrogen fixation, and then again returned into ammonia or ammonium. Then nitrification, nitrate in the soil, then nitrate. Some of that soil is denitrified, so it's just lost into the atmosphere and again becomes just nitrogen in the atmosphere, just nitrogen gas. Okay, the last one will be phosphorus cycle. So phosphorus, we'll start again, comes from different sediments, guano, and fertilizers. So this one is a little different because this one you'll actually get it from soil. Okay, so this is a nutrient that actually comes from the earth. So you can actually get it from mining. So just the rock beds and mountains, it becomes fertilizer that goes into agriculture. So the land and food webs uptake the phosphorus, any kind of death. And then there is the leaching of phosphorus. So leaching of phosphorus or the weathering of rocks can actually lead into it being dissolved in the oceans, or actually becoming runoff in groundwater. So again, lots of this stuff is taken up from bacteria and other kinds of autotrophs. You will need to know this for the next FRQ, and just basically think of what would happen if one of these was cut off. Alright, and that is it. So page 77 is where you leave off. Alright guys, have a good night.